Okay, well, I want to try an experiment to investigate the nature of frictional forces. And part of that experiment relies on readings off of this demonstration scale. And you can notice that the numbers on the inside read in pounds, so the English unit for measuring force, but the numbers on the outsides are calibrated in newtons. So right now, I'm pulling with a force of 1 newton, 2 newtons, 3 newtons, and so on. So I'm going to apply that force to this wooden block. I want to grab it and pull. In fact, I'm pulling right now, but there's no way for you to know that, right? You can't see the difference between just pinching it and pulling it. So if I put the scale on here, we can measure how hard I'm pulling. And notice right now I'm pulling with a force of 1 newton, yet the block remains at rest. So picture a free body diagram for all the forces acting on this block. Right now gravity's pulling down, but then again the desk is pushing up. Those forces happen to be equal and opposite. And by the way, don't confuse that pair of forces as a Newton's third law pair. They happen to be equal and opposite, but they're both acting on the block, so therefore cannot technically be a third law pair. I think we say the desk pushes up on the block, so the block pushes down on the desk. That is a third law pair. Anyhow, forces along the y-axis, no matter what, are canceling each other out. The earth pulls down on the block, the desk pushes up on the block, they cancel one another out. Then along the x-axis, I pull with 1 newton of force, so friction must be pulling back that way also with exactly 1 newton of force. I pull with 2 newtons of force, the block is still at rest. Up just barely more than 2 newtons, and I broke what we call static friction, and the block begins to slide. Let's try that again. 1 newton, 1.5 newtons. Didn't quite get to 2 newtons. Now notice this. If I pull it with a steady speed, the amount of frictional force was just under 1.5 newtons. So it seems to be the friction, the maximum amount of friction that it can utilize in order to stay at rest is a greater value than the steady amount of friction when it's sliding. Let's try that one more time. See what the value of static friction is. It looks like the static friction can range anywhere from 0 up to some maximum value before frictional welding breaks, and then while sliding, it has a singular steady value of kinetic friction that's slightly less than the maximum value of static friction.